This is problem 1, analyzing student work for April 28th, Tuesday, grade 4. So analyzing student work, we're going to look at the student work. It says our student's name is Bo, and it says solve 1 and 1/3 plus 1 and 2/3. And the student said that equals 3. So to analyze work, first let's solve it ourselves. So we have 1 and 1/3. So I'm going to just write that down so I remember. And I'm going to represent that with a fraction model. If we know that our denominator is 3, we know our rectangle is going to be split into 3 equal parts. And we have one full rectangle, which is our whole number 1. And then we also have 1/3. So I'm going to put these together, and I'm going to shade in one more part to represent 1 and 1/3. We're adding 1 and 1/3 plus 1 and 2/3. So again, I'm going to write my second add-in, which is 1 and 2/3. And first, I'm going to represent the whole number, which is 1, and our denominator is 3, so we're splitting it into 3 parts. We're splitting it into 3 parts. Let me just move this over. And I'm going to color in all 3 of these, and then I'm going to add another rectangle because I know that I need to also represent 2/3. So I'm going to color in 2 parts. And because we are adding these together, I'm going to count the total pieces. So I see 1, 2, 3 out of 3 here, so 1 full rectangle here, and I see a full rectangle here. So I know 1 plus 1, or 3/3 plus 3/3 equals 6/3, or 2. So I have 2. And now let me add my fractions. So I have 1/3 here and 2/3 here. So if I move this here, I take this 1/3 and I add it to my other fraction 2/3. So I'm going to take this and get rid of this. Now I have one full group of 3/3. So one whole group, 3 shaded out of 3, is equal to 1. So I'm really adding 2 plus 1, and that equals 3. I can also represent 3 by counting the individual thirds and writing an improper fraction. So let's count those up. And I'm going to switch this third back just so we can count it all up as improper fractions. So 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, 7/3, 8/3, 9/3. So 9/3 I know is also equal to 3. So our job is to analyze the student work. So let's go back and check it out. Bo said that 1 and 1/3 plus 1 and 2/3 is equal to 3. Let's go back and check out our work. Oh, interesting. It seems like we got the same solution. So it says, answer these questions. Write a number sentence to represent the order Bo added each part of the mixed number on the number line. So let's look at his number line. He started at 0 and he added 1. So I'm going to represent that jump he did right here as 1. Then he added 1 again because he jumped from 1 to 2. So I'm going to circle this one in a different color, and I'm going to write my operation, which is 1, and write 1. Then he added 1/3. So in yellow or greenish, I'll circle this. And you can see he divided the intervals between 2 and 3 into 3 parts so we could represent those fractions. So next he added 1/3. And finally, his last jump you can see in red, which is right here. It shows 2/3 he added, or 2 intervals of 1/3. So plus 2/3. So it seems like he decomposed his fractions into whole numbers and fractions and added it all together. He started at 0 and he ended at 3. Does it matter what order Bo adds the number of... Does it matter what order Bo adds the parts of the mixed number? Take a second to quiet think. Would our solution change if we changed the order? Think about the commutative property of addition. If you said no, you are correct, because when Bo solved it, he added his whole numbers first. He added 1 plus 1, then he added 1/3 plus 2/3. When we solved it, one way we did it was just by adding each individual part. So really we decomposed. So if you added 1 plus 1 first, that's a great way to solve it, but it doesn't have to be done that way. You can decompose 1 and 1/3 into 4/3 like we did up here, and you can decompose, I'm just gonna note that, 4/3 because we had 4 parts shaded out of 3, and you can represent 1 and 2/3 as 5/3. Then you can add 4/3 with plus 5/3 and get 9/3, which we did our second round, and it brings you to the same solution. We're just moving around our pieces. We're not changing the values. So does it matter? No. And you can write a full answer there. We can talk about properties, what properties you know, and you can rearrange this expression to show your work. And then the final part says use the number line to show a different order that Bo could have added the numbers. So this is a great time to be creative. You can show your work right here, but we're going to start at 0. It just depends on what order we're changing these parts. So think about that and then go ahead and solve.